Did you know that the technology used to create the Shark Cam, the amazing device that has given us a glimpse into the underwater lives of sharks, came from something originally developed for the military? Stay tuned for more. Hello everyone, welcome to XSTEM All Access. I'm Erin Winick Anthony, and I'm excited to be a part of this series showcasing some of the coolest minds in STEM. As your guest host for this episode, I'm excited to chat with underwater robotics engineer Amy Kukulya. Now, Amy is a robotics engineer who specializes in underwater robots. She has designed and built autonomous underwater vehicles for many different applications, including conservation research, locating lost shipwrecks, tracking oil spills, exploring water under ice, and even military uses. I can't wait to explore the world of underwater robots and learn more about what it's like to have autonomy underwater. But before we go any further, let me tell you a little bit about myself. I have a degree in mechanical engineering from the University of Florida, spent 2 years working for MIT Technology Review as a journalist, and nearly 4 years at NASA as a science communicator. I now run my own science communication company, getting to learn and share tons of different areas of science and engineering through writing, video, social media, and more. I even sailed earlier this year on a 2-month scientific ocean expedition that used rocks from beneath the seafloor to study Earth's climate history. So I'm thrilled to be able to go into some more underwater science today. Now it is officially time to meet our speaker. Amy, welcome and thank you for joining us today.
Hi Erin, thanks so much. I'm really excited to be here again with XSTEM and talk about my favorite topic, underwater robots.
We are excited as well. Let's dive right into the topic of underwater robots, also known as AUVs or autonomous underwater vehicles. What is an AUV and why are they important?
Yeah, great question, Erin. Autonomous underwater vehicles, something that I've been working with for a long time, are also known as AUVs, are one of the 3 types of main underwater robots out there. So there's the submersibles that people go in, and then there's remote operated vehicles where you have to drive around with a tether. So the AUVs that I've been working with are completely autonomous. That means they drive themselves, so you don't need a person with a remote control. You don't need any human intervention. So think of these robots as usually they're torpedo shaped. They're filled with a lot of rechargeable batteries, similar to the batteries that are in your phones or your computers. And then they have a bunch of sensors on board, and sensors are the really important part of the robot. And the idea is that you use these robots as extensions of yourself to go into the ocean and to places that are hard for humans to go to, whether they're hospitable areas like in the Arctic or Antarctica. They're in hard to reach places. And they're also used to go into dangerous places, like in the event that there's a military interaction at a time of war, where there's mines that are put down in the water, in the ocean, on the seafloor, to prevent like humanitarian aid from getting into a country that needs it. These robots that can go in autonomously, drive themselves around, and use their onboard sensors, whether they're cameras or sonar, to be able to detect objects that aren't supposed to be there. So these robots are just fantastic tools to learn from, to explore with, and there's a long road ahead to be able to innovate them, to get them to where they need to be, so we can keep exploring and getting to these hard to reach places.
Incredible. Yes, our oceans cover more than 80% of Earth's surface, yet we know more about the surface of Mars and the Moon than we do about the ocean floor. How cool is it that these robots are giving us the opportunity to explore this relatively unknown part of our planet? Plus, they allow for us to venture into dangerous and hard to reach underwater places without leaving the safety of dry land. Now, Amy, you've designed and built AUVs for many different applications that we mentioned earlier, including conservation efforts, tracking oil spills, locating lost shipwrecks, and even exploring the icy waters of the Arctic. Another surprising application of AUVs is within the defense sector. So you talked a little bit about it in your previous answer, but can you give us some more examples of the types of AUVs that you've designed for defense applications?
Yeah, Erin, it's so true. It's one of the things that people don't know about are the defense applications, the sensors, and the robots that are used for the military. And part of the reason why that's true is because when you're working on with the military, a lot of what we do is sensitive. And by sensitive, I mean is classified. So you're not allowed to talk about the details of a lot of the things that we need to do to help the military. And so another thing that people don't recognize who aren't directly involved in the field of ocean robotics is that a lot of the funding and the baseline and the foundation for ocean robots has come from military funding. It costs a lot of money to develop robots, and the military has larger budgets to develop ideas, big ideas, really like groundbreaking ideas from scratch. And so a lot of the science work that I've worked on over the years has come from the root of military, some ideas, but in particular funding and being able to leverage that funding from the military. So some examples might be that the robot that I originally was working with, the first autonomous underwater vehicle to be commercialized, which is known as REMIS, was originally developed for science research, but then quickly got adopted by the military to be a mine countermeasure vehicle. And it was because that adoption by the military to use this autonomous underwater vehicle to drive around and detect man-made objects or anomalies on the seafloor, which are these mines, that vehicle technology took off and we were able to develop it and innovate it more rapidly. So some of the things that we think about when we're working with the military is that you have to be really stealth, right? You have to be quiet. You don't want anyone to see you. So if you don't want anyone to see you when you're in the water, you spend a lot of your time underwater. And we have these design considerations where we want the robot to be able to propel itself and drive itself and communicate, but we have to be as quiet as possible. So a lot of the development for military robotics isn't necessarily the robot itself, the platform, but it's the sensors, the things that you attach to it that collect data and communicate, and then the software on board is what we're constantly innovating to work on unique applications for the military.
Who knew that the foundations of underwater robotic technology originated in the defense sector? Really interesting that in addition to facilitating the exploration of our blue planet, these robots are also contributing to national security. So tell us about SharkCam and TurtleCam, robots that you helped develop. How are these devices helping us observe the ocean from the animal's perspective? And how are these robots helping us solve some of the planet's biggest conservation issues?
Yeah, Erin, the TurtleCam and SharkCam robots are like a great segue from questions talking about military applications, because another thing that people don't know, one of the backstories to SharkCam is that technology to be able to, I'll tell you more about it, but to be able to autonomously track a moving target underwater, follow it and film it, came from a military application where we were trying to make everything as autonomous as possible. And autonomy is a word that definition is constantly changing for it, but in this element of what I'm talking about, it's more of like trying to remove humans from the loop as much as possible, and getting the robots to be smarter and do things on their own. So SharkCam is a robot that's specialized where it has a bunch of cameras, 5 to 7 cameras on board, and it has a really special algorithm or software map on board that tells the vehicle a set of instructions. So you put the SharkCam in the water and it'll ping a tag. So a tag is like an underwater piece of equipment. It's a transponder, and a transponder is this beacon that sends sound waves. It can listen for sound waves, and then it can send sound waves back to whatever is trying to communicate with it. So think of the game Marco Polo, where if you're out swimming and you have your eyes closed and all you hear is sound, and somebody says Marco and then you reply Polo, you know how far away something is by the sound of their voice. Is it getting further? Is it closer? So we're able to do that underwater by using time estimates. So if I'm the robot and you're the shark, and I'm pinging and sending a ping out through the water, the tag on the shark will listen, respond back. So I know what time, I've looked at my watch and I know what time I sent that ping out, and then I know what time I received it. So I'm able to do some onboard math to determine the distance that that signal has gone by knowing how the speed of sound travels underwater. So there's a little bit of math, there's a little bit of understanding, temperature, and the saltiness of the water to determine how fast sound can move in a particular area. So by constantly sending these pings back and forth to the tag, you're able to know exactly where that animal is, and then you can swim your robot to get as close as you want to. Why that's important is that there is no other capability in the world right now where you can autonomously use this robot and follow a megafauna like a shark or a big sea turtle. And the really interesting thing is about these large animals who live in the ocean, they're so large and you can see them with your eyes, but they spend most of their time underwater. And so you have no idea like what they're doing most of the time, except for that little bit of a glimpse that you might get at the surface every now and again. To be able to understand more about what these animals are doing and how they're spending their time, then you're better able to protect not just them, but the environment that they're living in, and this information can help with conservation efforts.
Speaking of future roboticists, it must require a diverse group of skilled professionals to design, build, and maintain these underwater robots. Are there any specific jobs or skills that are required for working on AUVs that might surprise us?
Yeah, Erin, it's an excellent question because it takes a village to build effective autonomous underwater vehicles. So it's not just engineers and of traditional disciplines like mechanical, electrical, software. There's a lot of smart people out there, right, who are developing new technology, and being smart and understanding the engineering disciplines is important. But what's also equally important is having creativity and also passion about what it is that you're trying to do in order to make effective technology. So some of the things that go into it are also sourcing materials. There's like machine shop skills and having machinists be able to understand how to manufacture something that's going to be potentially bitten by a great white shark. Could be operating in highly acidic areas, or really cold and really hot extreme environments. So material scientists, machinists who can make seals and housings and understand different materials, and also in additive manufacturing, 3D printing, machining skills on CNCs and lathes. We need people who can weld. I mean, it's not just the robot. There's so many things that go into it as well, and launch recovery systems. Corrosion is a big problem that we have to worry about as well. So there's different types of paints that we're constantly trying to figure out that can work better in an environment where there's a lot of algal growth and things that can corrode metals. So we're looking to the military often to be able to help us define and see what are these like futuristic materials that they're already using, and the skill sets that are needed are, like I said, it takes a village of different people with a wide variety of backgrounds to offer their expertise. And now the military has a new position for the first time that specializes in autonomous underwater vehicles and robotic technology, which is going to be a game changer for helping to further push the envelope on underwater robots with this inclusion of this career opportunity in DoD.
So if you're watching and have an interest in working with underwater robots, but thought you'd have to get an engineering degree first, that's not the case. You mentioned a few different machining skills used in the manufacturing of these robots. One of my personal favorite things that I got to do while getting my mechanical engineering degree was work directly on the machine shop floor. Let's take a closer look at machine tooling and CNC machining, two related but distinct manufacturing techniques and elements that are critical for building robots and many other devices. Machining really is such an important skill to have in so many STEM-related jobs, including robotics. Now, shifting a little bit, Amy, how does artificial intelligence or machine learning play a role in the autonomous vehicles that you work with?
Erin, AI and machine learning is huge. These new technologies and software development are what exactly was needed to get over the hump of how we've been able to advance autonomous underwater vehicles and underwater robotics in general. So when I first started out doing this, we used to say that robots were only as smart as the person who programmed them, and these AUVs would basically be launched in the ocean and follow a pre-set instructions, right? A mission that was pre-programmed. It would go mow the lawn and swim monotonously in a pattern and just do what it was told, but never adapt from that mission. So now with artificial intelligence and machine learning, the vehicles are able to get smarter when they're operating in an environment. So they're given a set of instructions and they're given some leeway, and to be like, okay, I want you to turn on a sensor that can measure how salty the water is. And it could be swimming along, and all of a sudden it finds a patch of water that's really salty. And when that happens, it can turn on another set of sensors. And in that case, maybe you'll turn on some cameras because you want to see if there might be some other marine environments that can operate and exist in a really salty environment, or maybe there are ones that can't. So with the implementation and the advancement of these new software capabilities, the vehicles can think on their own, make new decisions, and gain valuable data, and honestly, oftentimes become their own little scientists. And there are limitations with it, but the more times you put a robot in the water and collect a new data set, you're able to use that data to train the algorithms to create smarter algorithms, and then the iteration just keeps continuing, and it's endless. So that work in software development is huge, and I think one of the probably most up and coming and much needed disciplines for students to get involved in.
The idea of training robots to learn is so cool to think about. Let's face it, artificial intelligence is all around us. From our smartphones to the cars we drive to life-saving healthcare and the manufacturing of products that improve our lives. I agree. AI is such an important discipline for students to learn about right now and understand so that they can apply it to help make our world a better place. Here's some more information on artificial intelligence. AI and machine learning are definitely technologies of our future. Now, Amy, you must encounter some unique challenges when designing a robot to operate underwater for long periods of time. How do you assist an AUV that encounters an issue from potentially a very far distance away?
Yeah, AUVs have some major limitations, and that is duration that they can be deployed without running out of batteries, and being operated in far away places that are hard to get to. I think that those greatest limitations are where some of the greatest advancements can happen. So an example on a program that I worked on for a number of years was being able to develop a helicopter portable autonomous underwater vehicle that can go for weeks to months at a time, be deployed in the Arctic through an ice hole, and then stay under the ice, because oftentimes when you're in these faraway places, they're really hard to get to, right? They're far away and they're expensive to get to. But in ice-covered regions, the weather windows are quite small where you can go in there and respond to like your robot needing help. So the robot has to be able to help itself oftentimes, or be able to sit still for periods of time without getting destroyed, and have some backup intelligence to keep it going and alive until you can get to it. So some of the things that we think about is, okay, if I have this robot, I need it to, instead of lasting hours, which is typical, to last for days. So here's a couple things that we do. You add as many batteries as you can, but keep in mind that another thing that people want is for these robots to be as small as possible, right? So then another way of thinking about that, or to solve that problem, is to try and use as little power as possible. So when you're operating underwater and this vehicle is flying, only turn on the sensors that you need. You want to be able to find other ways of going up and down in the water column without having to actively drive yourself with its onboard propulsion system. So one way to do that is to use what we call a variable buoyancy system. So you can literally change the overall buoyancy, or how much you weigh in the water, by taking in either seawater or oil inside or outside of the vehicle. Another way is to drift with water currents. So the more we understand water currents, the more we can use them to our advantage. Maybe a lot of you have seen the movie Finding Nemo, and where some of our major currents are around the oceans, you can use those to your advantage to be able to move from point A to point B. You also have to think about corrosion, and I mentioned this earlier. One positive thing about working in a cold environment is that corrosion isn't as much of as an issue, but also algal growth is definitely not an issue, because things can't grow so much in cold places. But that's one of the things that we think about. It's one thing to be able to go for long periods of time, but if you're in a warmer, more temperate part of the ocean, you're going to have issues with more corrosion, and also issues with algal growth growing on your vehicle, and maybe preventing things from moving and working so well, or growing on the lenses of your cameras. So you just have to know, once you're aware of what these problems are, there's always going to be a solution that you can implement with you and your team to get around it. And that's a constantly evolving iteration. That's what makes the design process of working on underwater robots so much fun.
Corrosion control in manufacturing and engineering is very important because it increases the lifespan of materials like metals. The corrosion of materials and the items that make up our world can have an environmental, economic, and safety impact. Let's take a closer look. Okay, so I noticed this quote on your website. If it doesn't exist, you need to build it, then share. Has this methodology contributed to your career path and achievements?
Yeah, that is something, we all have our mantra, Erin, where you have to say something to get yourself out of bed in the morning, maybe, or, motivated to just be your best self and innovate and push the envelope, and when you're putting on your thinking cap, and, what are you going to accomplish today? And there's so much pressure in this world to succeed. You can easily get yourself disheartened by thinking like everything's been invented before, but that's actually not true. And that's why I think once you come up with a good idea, or you innovate on another idea, and you're collaborating with your colleagues, it's important to always remember, like, what good is the work that you're doing and what you're learning and what people have done before you if you can't share it? So I'm a big fan of developing things that can be open source, that other people can contribute to, and that people know, what's possible. You share your knowledge, you share your technology, and there's a point where if you have a good idea, if no one knows about it or it's hard to find, then it's not necessarily going to be the best implementation of what is possible from what you can contribute to society. So I think collaboration is key for success and pushing the envelope for underwater technology and conservation efforts across the globe.
I love the idea of having a mantra that motivates you to keep moving ahead to pursue your dreams. If you find yourself struggling to stay focused on your goals, maybe finding your own personal mantra could help. I always personally try to stay self-aware and assess every few months to make sure what I'm working on aligns with my personal goals. All right, Amy, thank you so much for joining us today.
Thanks, Erin. It was really exciting to be here, and I want to particularly thank all the students for tuning in. And I want to remind everybody, failure is what we learn from the most. So when you experience failure for the first time, welcome it and keep on going.
That is so true. Amy, I really enjoyed chatting with you about the exciting world of underwater robots and learning about the diverse skills required to create and maintain these devices that help us explore hard-to-reach places. And thank you for tuning in today. Make sure you subscribe to the YouTube channel in the description below and follow us on social media to get updates about new episodes. You won't want to miss any of them. Plus, you'll get access to fun weekly content for students and teachers. And don't forget to check out the full library of episodes available on demand right here. Each one has a NGSS-aligned lesson plan for teachers to use in the classroom. And each lesson also includes a social-emotional learning component. With your parents' permission, tell us how you were inspired today by tagging us at USA Science Fest, #XSTEM, and me at Erin Winick. And keep up with me through social media here. I share tons of fun videos about space, my own ocean adventures, science, and even my competitive pinball hobby. I had a blast being your host today, but don't sign off just yet. You'll want to stick around through the end of the video for a fun trivia game that you can do in the classroom or at home. Have fun and good luck!